Today, on how it's made. Drill bits. The whole story. Photo booths. A picture-perfect product. And stamps. A special two-part report on the hallmark of snail mail. Drill bits are attachments you fasten to drilling tools. A taper point drill narrows to a point so the threads of the screw grab the wood. A countersink makes the top of the hole the same diameter as the screw head so that the head lies flush or below the surface. A plug cutter removes a round piece of wood with which you plug the hole afterwards to hide the sunken screw. Countersinks and plug cutters start out as steel bars. To make a countersink, this computer-guided tooling machine uses what's called a center drill to pierce a starting hole, then switches to its main drill, which bores right through. Next, it uses what's called a rough turning tool to shape the countersink's angled nose, then its body. The machine now switches to a milling cutter. This tool shapes the countersink's 4 blades. A cross-drilling tool bores a hole for the 2 screws that'll hold the countersink to the drill. A tap cuts threads into the hole. Next, a tool called a dovetail cutter sharpens the blades. Then finally, a cut-off blade removes the tool. The same machine makes plug cutters. Its center drill makes a starting hole, but this time, the main drill doesn't bore right through. It stops at the depth that the plug cutter is designed to cut. Just as before, the rough turning tool shapes the body, and the milling cutter sculpts the 4 blades. Some plug cutters on the market have fewer blades. This company makes 4, so the cutter will clear the wood chips more efficiently when it tunnels into the wood. After the dovetail cutter sharpens the blades, a tool called a boring bar refines the hole in the center, making it the proper size. Another turning tool now forms the shank, the stem of the plug cutter that you insert in the power tool. Then the cut-off blade slices the tool off. Now for some manual touch-ups. First, they grind the plug cutter against an abrasive wheel to remove excess metal from the cut-off. Then they do what's called side chipping, grinding the sides of each blade to a particular shape that'll clear the wood chips. Here's how the plug cutter looks before and after grinding off the excess, and before and after side chipping. And now for making the drills to which the countersinks attach. It all starts with a tapered piece of steel, because this will become a taper point drill. Straight drills begin with a straight piece. A mechanical arm inserts this drill blank, as it's called, into a computer-guided grinder. The machine has 2 wheels made of boron nitride granules, a natural material that's tough and abrasive. The first wheel shapes the smooth blank into lengthwise spirals called flutes. A second wheel then grinds sharp cutting edges on the flutes and shapes the tip of the drill to a point. Back to the countersinks now. The steel is still relatively malleable, so a worker runs each one through a stamping machine that imprints the size of the tool and the company name. Whereas the drills are made of a different type of steel that's already hard enough, the countersinks and plug cutters must undergo a heat treating process to harden, about 20 minutes in a fiery oven, along with a secret recipe of chemicals. The intense heat, 955 degrees Celsius, transforms those chemicals into gases which then permeate and harden the steel. After cooling in warm water and oil for about 15 minutes, workers submerge the tools in an industrial-strength cleaning solution that removes all the oil grit. Then a bath in acid to remove soot from the oven. Then finally, 20 minutes in a blackening solution, the ingredients of which are again a closely guarded company secret. This last step is purely cosmetic. So, how do the 3 drill bits we've seen all work together? First, you use the plug cutter to make the plug. Then you pop out the plug with a screwdriver. Next, mounting the countersink, that black tool, onto the taper point drill, you drill a hole for the screw. Then you drive the screw into the hole, sinking it below the surface. Then you cap the hole with the plug. These tools come in an extensive range of sizes and grades for both amateur and professional woodworkers, and for industrial machines. Photo booths were first introduced in the 1920s in the United States. Today, the small private cabins still enable us to be kooky in several snapshots or one large picture. The booths are quaint reminders of our pop culture, but they use the latest technology to make portraits worth treasuring. This model simulates a painting or drawing based on the photo it takes of you. To customize the pre-assembled cabin, a worker applies stickers to the outside. These advertise local businesses or the booth's eventual location, such as a shopping mall or amusement park. Inside, there are 5 shelves for equipment. 2 layers of plexiglass glued together will act as safety glass, protecting the equipment from vandals. It fits over an opening in the wall that divides the seating area from the camera and a TV monitor. The worker installs a metal plate in another opening. It will cover the coin acceptor and give the booth operator access to the money people pay to have their photo taken. The coin acceptor attaches to brackets on the back of the door. They'll program it to accept tokens or specific currencies. A black and white photo usually costs $3, color is $5. This 15-watt bulb provides some light for your photo. It goes in a panel that fits into the wall. Next, a motorized tripod to hold the camera. In this model, they use a digital camera with an 8mm lens. Up and down buttons on the control panel adjust the camera angle. A computerized voice from a speaker will prompt you to make selections. A fan attaches to the ceiling to vent the cabin and keep the equipment from overheating. And 2 40-watt fluorescent lights will provide most of the frontal lighting for the subject. Another 15-watt light behind a frosted panel provides some diffuse light. The booth's power panel has connections for up to 19 pieces of equipment. Here, a worker plugs in the camera, then a TV monitor, and an inkjet printer. Software will process the photos, and the printer will print them on photo-quality paper. A plexiglass window protects a 38-centimeter monitor that's used for viewing and making selections. 2 other monitors fit in windowed panels on the outside of the cabin. The monitors all connect to the computer and show the same images at the same time, including what stage of development your picture is at. They install a dispenser that sells optional cardboard frames for your portrait. Money from these sales falls through a slot into a metal coin box inside the cabin. The dispenser holds up to 100 cardboard frames, each large enough to hold 1 portrait measuring 20 by 28 centimeters. If the dispenser's out, a sign reading "out of frames" drops into the tray. For security, the 2 doors enclosing the equipment each have 2 key locks, one at the top and one at the bottom. The worker installs 4 signs on the cabin roof. They're plexiglass boxes with vinyl posters and fluorescent lights. The cabin's curtain lets you make goofy faces in private, but is short enough to let people know you're in there. Inside the cabin, the control panel helps you guide the camera. You press up or down to adjust the camera angle, Then you choose one of the 3 photos the camera has captured. The computer bases its portrait on this photo. You can tell it to make a caricature, a simulated work of art, or 4 small portraits in different artistic media. You can choose an oil painting, a pencil sketch, or a drawing in charcoal or pastel. Now you've got a masterpiece you can really identify with. The world's first postage stamp was introduced in England in 1840 as part of a major reform of the postal system. Until then, the letter recipient had to pay the postage. This first stamp was called the penny black because it cost 1 penny and featured Queen Victoria's profile on a black background. Today's postage stamps feature all types of illustrations. A graphic artist produces a design concept, working the computer cursor like a paintbrush on canvas. This concept goes to the Postal Service's Design Authority for approval. Once approved, the design goes to the printing company. The printer produces one type of stamp using 2 different types of printing presses, one of which requires an engraved printing plate. The company's master engraver draws his artistic interpretation of the concept using photographs of real subjects for inspiration. Then he paints his drawing in watercolors. The shading is key because it indicates where the engraving will have depth. This helps him envision the end product. Once he's happy with the result, he scans the image into a computer and shrinks the digitized image to the actual stamp size. Then he lays a sheet of clear acetate over the reduction. With a tool called a point, he etches the main elements into the sheet. This etching process is known as scribing. Now he tapes the scribed sheet onto a piece of soft steel. He lifts the sheet and coats the metal surface with beeswax. Then he lays the sheet down again and, rubbing with a burnishing tool, transfers the scribed image to the wax coating. Now, under a microscope that magnifies the image 7 times, he etches the design using what's called a pointing-in tool. Then he sharpens another tool called a lozenge graver. With that, he deepens the etched lines of the design's focal point. This adds depth, which will make the deer appear almost 3-dimensional on the finished stamp. Once complete, the engraving will be copied multiple times onto a plastic master plate. Workers coat the plastic with silver so that it will conduct electricity, then submerge it in a bath containing baskets of nickel. They run an electric current through both the bath and plate. This dissolves the nickel and draws it onto the plate in a thorough and even coat. With a nipping tool, workers remove the excess nickel along the perimeter, then extract their nickel printing plate. Then they plate the nickel plate in chrome. Now it's ready to go onto the intaglio printing press, a specialized machine used to print only select elements on certain types of stamps. We'll explain why later. This machine, meanwhile, produces the templates for carving what are called shablons, the rollers on the intaglio press that transfer ink to the printing plates. Here, the machine traces a pattern for one of the stamp's intaglio elements, guiding a router on the other end to reproduce it in half the size in thick plastic. At another machine, meanwhile, a worker makes the shablons. He takes several ingredients, what they are is a closely guarded company secret, and pours them into a roller forming machine. The mix heats to about 180 degrees Celsius, and over about an hour and a half, it thickens and hardens. Now, an automated router machine with multiple heads goes to work. Following the plastic template, the heads carve away at the rubber, leaving behind a raised design in the shape of the elements the intaglio press will print. It's this raised area that transfers the ink to the printing plate. Why do they print some parts of a stamp using one type of press and other parts of it using another type? Simple. Offset printing presses are widely available, so if the entire stamp would be printed using that technology, counterfeiters would have it easy. Intaglio printing presses, on the other hand, are harder to come by, making fake stamps harder to produce. The sheets first run through the offset press. It prints one color at a time, inking a separate printing plate for each color. The plate is wrapped around a cylinder. As it revolves, the plate transfers, or offsets, the ink image to a rubber cylinder rotating against it. As that cylinder turns, it transfers the image to the paper passing underneath. A Postal Service official inspects the press output. Using a magnifying glass, she scrutinizes the color and print quality, circling any problem areas for the press operator to investigate and correct. Now the offset printed sheets move on to the intaglio press. The intaglio's shablon rollers spread ink over the printing plate the factory produced from the engraving. The ink fills the recessed lines of the image. The press runs the plate against the paper sheets, transferring the image. Intaglio printing leaves the ink slightly raised above the surface of the paper. This gives the image height, a third dimension. Once again, the inspector checks the result. It's up to the press operator to correct any error. The cause can be as complicated as a printing plate problem or as simple as a speck of dirt in the machine. The printing now done, a worker loads the stamp sheets into a computer-guided perforating machine. Grippers pull the sheets forward one section at a time. Down comes a die with rows of steel pins, each just a millimeter in diameter. They punch through the sheet, framing each stamp with tiny holes spaced precisely 1.5 millimeters apart. The machine knows just where to punch these perforations by reading the line of fluorescent ink that runs along the borders of each stamp. This ink, called tagging, is visible only under ultraviolet light. Tagging also plays a role later on. The automated machines that process mail at the sorting plants are programmed to scan for tagging. They reject all envelopes without it. Those letters are either missing a stamp or bear counterfeit postage. After stacking the perforated sheets, workers trim them down to the finished size, usually sheets of 10 called panes. The trimming machine is appropriately called the guillotine, but unlike the head chopping version, this one slices with a sideways shearing action. That puts less wear on the blade. The machine holds the stack in place with 4,000 kilograms of pressure so that it doesn't budge under the weight of the blade, which rings in at almost 32 kilos. Now it's time to group the panes into manageable-sized packs for post offices and other stamp retailers. This machine is called a vacuumatic counter because it uses suction to draw the panes across a paddle wheel, which counts them. This stack adds up to 503 panes, so the worker removes 3 to make an even 500. The counter inserts a tab between every 50. Some stamps go through what's called bursting. the process of manually separating pairs of stamps for different post office product lines, such as gift sets. Some burst stamps go onto first-day cover envelopes, one popular collector's item. An automated pad picks up the stamps and runs them against a wet roller that activates the adhesive on the back. After a worker positions an envelope against a guide bar, the pad places the stamps in a precise spot and applies even pressure over them so that they'll lay flat and adhere securely. Most stamps are still the old lick and stick type, printed on paper that's coated with a moisture-activated adhesive on the backside. However, the most commonly issued stamps, known as definitives, are printed on what's called pressure-sensitive paper. That's the technical term for peel and stick. No water or saliva required.